In this lesson, we're going to talk about how to factor a difference of squares. By the end of this lesson, you should be able to factor binomials that are considered differences of squares. When we talk about differences of squares, it's important to recognize what a perfect square is. So a perfect square is a rational number whose square root is also a rational number. Usually, it's a whole number whose square root is a whole number. When we're factoring a difference of squares, we're looking for two perfect squares that are going to be separated by subtraction. And how they can be factored is by taking the square root of a squared, taking the square root of b squared, and then rewriting it so that it's a plus b times a minus b. So remember that the square root of a squared is a, the square root of b squared is b, and then we rewrite it so that it's a plus b and a minus b. When we're doing a difference of squares, you may need to factor or may need to do the difference of squares more than once. So just kind of keep that in mind. You want to pay careful attention as to not mix up a difference of squares with the sum of squares, which is separated by addition and which cannot be factored. So you want to pay careful attention as to not mix those two things up. If we look at 1, we see that m squared minus 49 is a difference of squares because m squared is a perfect square and 49 is a perfect square. So in order to factor this, we want to take the square root of m squared, which is m, take the square root of 49, which is 7, and then we write it as m plus 7 and m minus 7. That is going to be our factored binomial. So we take those two square roots, we write it as two binomials, one with addition and one with subtraction. And then if you FOIL to check, you should get m squared minus 49. Again, let's do the same thing with a squared minus 4b squared. We take the square root of the first term, which is a, the square root of the second term, which is 2b, and then we write it as the product in of a sum and a difference. So that would be a plus 2b and a minus 2b. Now, before we factor differences of squares, just like with everything else, you want to pull out the GCF first. So when we look at 9x squared minus 36x squared, the greatest common factor that can be pulled out of both of these numbers is 9. So I pull out a 9, I factor out a 9. We're left with x squared minus 4y squared. And then we factor the difference of squares on the inside. So I know that the square root of x squared is x. I know that the square root of 4y squared is 2y. And so my factor is going to be 9 because we pulled out the 9. And then when I factor the inside, that's x plus 2y and x minus 2y. Now remember, we always pull out a GCF first so that we ensure that when we factor that it's fully simplified. When I look at b, the GCF that can be pulled out is 8. So when I factor out the 8 from 32, that's 4. Minus y squared. Again, this is helpful because before we didn't see a difference of squares because 32 is not a perfect square and 8 is not a perfect square. But when I factor out the GCF, I can see that we have a difference of squares now. Square root of a is 2. Square root of the second term is y. And so again, one of my factors has to be 8. And then the other factor will be 2 plus y and 2 minus y. When we look at 36z cubed minus 9z, the GCF that can be pulled out is 9z. And what we're left with is 4z squared minus 1. Almost wrote 3, but that's minus 1. Again, I've got 9z and then I can factor the inside as a difference of squares. So 4z squared, that would be 2z. 1, square root of 1 is 1. So my two factors are 2z plus 1 and 2z minus 1. And then 9z. So I've got three factors here because we factored out the GCF. Now, remember that you may have to factor more than once. So if I take the square root of x to the fourth, that's x squared. If I take the factor of 256, that would be 16. And so I have x squared plus 16, x squared minus 16. Now, x squared plus 16, that's a sum of squares. So remember, that can't be factored, so I'm going to bring that part down. But x squared minus 16 is another difference of squares. Again, the square root of x squared is x. The square root of 16 is 4. And so my two factors would be x plus 4 and x minus 4. We look at 2x to the fourth minus 32. Remember that we want to factor out the GCF first. So my greatest common factor that can be pulled out is 2. So we got 2x to the fourth minus 16. I can factor the difference of squares here. That would be x squared, and that would be 4 for their square roots. So that would say, hey, 2 times, so I have my GCF here, x squared plus 4, x squared minus 4. Now I can't do anything with the x squared plus 4, because remember, that's a sum of squares. But the x squared minus 4 can be factored further, because that's still a difference of squares. Square root of x squared is x. Square root of 4 is 2. So far we have 2 times x squared plus 4. That part we can't change. But the x squared minus 4 will change to x plus 2 and x minus 2. So in this case, we actually have 1, 2, 3, 4 factors. When we look at differences of squares, it's important for us to keep in mind real-life application. So let's examine the following problem. If a car skids on dry concrete, police can use the formula to approximate the speed s of a vehicle in miles per hour given the length d of the skid marks. If the skid marks are 54 feet long, how fast was the car traveling? So, if the skid marks are 54 feet long, then in the equation, d would be 54. Now, we want to factor this. So when we're factoring this, we want to get everything equal to 0. So 1 over 24 s squared, subtract the 54 from both sides, gives us 0. Now, it might be easier for me here if I get rid of the fraction, multiply everything by 24. The fraction will go away. 54 times 24, I believe, is 1,296. And then that's equal to 0. Now, I see a binomial here, and I'm tempted to assume that this is going to be a difference of squares. And so because I think it might be a difference of squares, I want to look to see what the square root of 1,296 might be. And so for this particular case, that would be 36. So we have s squared, the square root of that is s, 1,296 square root of that is 36. So my two factors are going to be s plus 36 and s minus 36, which is equal to 0. Now, we're solving a polynomial. Remember that once we factor it, we can set each factor equal to 0, following zero product property. So if s plus 36 equals 0, s minus 36 equals 0. So if s is equal to negative 36, we have s is equal to 36. Now, only one of these answers makes sense. You cannot have a negative speed, and so our answer would be positive 36. It's traveling 36 miles per hour. This is how we factor using a difference of squares.